Hey guys, welcome back. We're on the downhill slope of this assignment. Now, if you didn't know anything about factoring before this assignment is pretty long. I'm assuming that you probably knew a lot of this and you were able to skip a lot of these videos. I just wanted to make sure that you had plenty of resources starting off tomorrow so that you weren't, freaking out and on your own. But we're on the downhill slope here, and I'm anticipating this homework assignment didn't take you quite as long as it took me to explain it. But if it did, then that's some work that you need to put in anyway, because this is important stuff that you need to know. The rest of this worksheet, it's about special cases of factoring. So you can actually factor the things that we're going to factor here, and then in the last little bit, you can factor using the old methods that we've used, the ones that I already showed you. But there's a faster way to do it if you can recognize some patterns. So let's look at problem 21 and 22. Now these, again, these aren't factoring problems, just like what I've been trying to set it up this way, so you have a couple foiling and then a couple factoring that kind of are opposite of each other so that you can see these patterns. To be good at factoring, you have to understand foiling and distribution really well. If you don't understand those very well, then factoring is really hard because it's the backwards version of them. So let's take a look at this one. Now, all we're going to do is foil, right? And foil, again, stands for first, outside, inside, last. We've done a lot of foiling on this worksheet so far. Let's do some foiling. So first would be x times x, right? X times x is x squared. Okay, outside, that's going to be x times 4. So that's 4x. Inside is going to be negative 4 times x. That's negative 4x. And then last will be negative 4 times positive 4, which is negative 16. Okay, the middle terms are going to cancel out here because we have a positive 4x and negative 4x. So when we combine like terms, those go away. And we could write 0x if we wanted to, but 0x is just 0. So pretty much what we do is we just kind of leave it like that. X squared minus 16. Okay, now this is a little bit different than what we saw before, because before, when we multiplied two binomials, we got 3 terms instead of 2 terms. In this case, the 2 middle terms cancel out and we end up with 2 terms, which is really kind of strange. What we call this guy right here is called a difference of squares. Okay, this is x squared, and this is 4 squared, and this is a difference, right? Difference means subtract. So x squared and 4 squared, and there's a difference here. The reason why that happens is because these two signs are opposite, and we call that a conjugate pair, if you recall. This is a conjugate pair, this guy and this guy. They're the same two pieces, x and 4, but this one has a minus 4 and this one has a plus 4. In other words, the middle sign or operation, depending on how you want to think about it, is opposite. And when that happens, the middle term drops out. We've talked about that quite a bit. I'm hoping this is familiar for you, but again, this is just to make sure you have every resource that you possibly could need to be able to complete this assignment. Let's look at the next piece here, number 22. Okay, same kind of a situation. These are conjugate pairs as well, so we should expect something very similar to happen here. X times x is x squared, just foiling here. X times 7 is 7x. Negative 7 times x is negative 7x, and then negative 7 times positive 7 is negative 49. Okay, so x squared, the 7x and the negative 7x cancel. They give us 0x, which is 0, and then I got the minus 49. Okay, so notice this is another difference of squares. Difference meaning there's a subtraction. This is x squared, this is 7 squared, so this is a perfect square, this is a perfect square, and this is a difference. So the difference of squares. So kind of a little mnemonic or a little rhyme for you is difference of squares come from conjugate pairs, or conjugate pairs gives you a difference of squares. So that's important to know. Now that's just foiling. That's not factoring, right? That's foiling. Factoring is going opposite. So let's take a look at 23 and 24 and see if we can figure out what's going on. Okay, now if we look at this one, this should look very similar than to 21, right? This time we're trying to go opposite. But let's say that we didn't have this. Let's say we didn't have this problem 21. We just wanted to factor it. Well, there's a couple ways we could think about it. The first way is to think about it as a difference of squares, right? You notice, okay, this is a difference of 2 perfect squares. Difference meaning subtract. This is k squared, and this is 4 squared. Okay, so you know that difference of squares come from conjugate pairs. Just by experience, you know that this comes from something like this. We need, oh, sorry, I was writing an x. We need a k. K up here and a k up here. Okay, now the second terms, they have to, or the last pieces of these binomials, they have to be opposite signs, otherwise we're going to get k pieces. We got a k squared and we got a number, but we don't have any just plain k's. So they got to be opposite and they got to be the same number. That's the only way we're going to get the middle terms to cancel, right? Now this is basically what we had up here, but opposite, so we kind of knew that that was the case. Let's say we didn't know that, though. Let's say you didn't recognize that as a difference of squares. I recommend that you learn how to recognize them, but if you didn't, you could still say, well, where's the k piece? Well, it's just 0k, right? Looks like OK, but this is 0k. So since we don't have a number out here in front of k squared, all we have to do now is find factors of 16 that combine to give me 0. Right? So I take c and I put it here. They got these two numbers that go in here. They got to multiply to give me this. They also have to add to give me this. So the only way I can get 0 by adding is to have the same number, but one's positive and one's negative. So you think to yourself, okay, the two numbers that I need have to multiply to 16, so it's got to be, and they got to be the same. So that's 4 and 4, but one of them has to be negative. Okay, so then we take these numbers. Now again, since there's no number out here, we don't have to worry about factoring by grouping right now. Right? There's nothing multiplying this. So this is just as simple as saying, okay, well, it's k minus 4 and a k plus 4. Okay, that's it. That's all you need to do. So, either way, you're going to get there. If you're not sure and you don't know this is a difference of squares, you can still just factor it like normal. You could actually factor this by grouping if you wanted to, and I'm going to show you how to do that on the next one. Now, it's overkill. You don't need to do that, but I'm just trying to demonstrate that the techniques that I showed you still work. So again, this is a difference of squares. So hopefully, at this point, you should be able to say, look, that's 7 squared, and that's v squared. So this has got to be v plus 7, v minus 7. Or v minus 7, v plus 7. It doesn't matter if you switch the order of these two terms, right? But let's say you didn't know that. Okay, so again, you got v squared plus 0v minus 49. So you're like, I don't have that middle term, I'm going to write it out. Again, this is not how I would do it, but I just want to show you that it's going to work regardless. Okay, v squared plus 0v minus 49. So let's do this by grouping this time. Okay, now again, it doesn't have a number out here in front of v squared, so I wouldn't do this by grouping, but I just want to show you that if grouping is your only factoring strategy, it'll still work. So this is a 1. Let's multiply it. 1 times 49, negative 49 is negative 49. Okay, and they need to combine to give me a 0. So this could be my grouping number, if you want to think of it that way, because it's still a times c, right? This is a 1v squared. So I still get my grouping number. The two numbers that multiply to negative 49 and add to 0 have to be negative 7 and 7. Okay. Now, instead of just throwing those in parentheses like I did over here, which would still work, by the way, let's factor it by grouping, just for giggles. So v squared minus 7v plus 7v minus 49. Right? I'm taking the negative 7 and 7, and I'm splitting the middle term here. Okay, here's negative 49, here's v squared. Okay. Now I'm going to factor by grouping. These have a v in common, so v times v minus 7. These guys have a 7 in common, so 7 times v minus 7. We'll factor a 7 from both of those. And then lo and behold, hey, those are the same parenthesis terms. So if I factor that guy out, I'm left with this v and this 7. And I'm still going to get the same thing. Okay. So the idea here is, yeah, it's a difference of squares. I hope you can see that. I hope you start recognizing that. But you can still factor this by grouping, and it's going to work, as long as you know that middle term 0v. Over here, you could still factor it like a regular trinomial, as long as you know that that's a 0k. So those techniques that we had, they still work on these simpler problems, but there is a pattern here that if we recognize, we can get a little bit faster at these. So let's look at these last two. Now these we're just going to kind of go straight through because we don't really need to reinvent the horse. We don't need to solve these more than one way. This is a difference of squares, right? Difference of squares comes from conjugate pairs. So x and x up front because I need to multiply to get an x squared. The two numbers that multiply to 36 but combined is 0 is 6 and negative 6. In other words, let's just take the square root of that number, square root of 36, 6. Let's throw them in there and let's make 1 plus and 1 minus. And again, the order doesn't matter. I could have x minus 6, x plus 6, and that's fine. Okay, same thing here, right? This is x squared, this is 9 squared, and this is a difference. So a difference of 2 squares. So I know I'm going to have something that looks like this, again from experience, basically. This is basically a special case of factoring a trinomial, excuse me. And the numbers that go in here are 9 and 9. And if we wanted to this time, we'll put the minus here and we'll put the plus here, and that's okay. That's perfectly fine. Okay, so that is how you factor a difference of squares. Now they can get a little bit more complicated than this, but we're just going to kind of save that for now. I just want to get these basics down. We'll probably come back and do some more factoring before the end of the year. We'll probably review factoring again because this is just a foundational topic that you need to have. But we'll end the video there for now. I'm going to move on in the next video, move on to the last problem set, and then you should be good.